on fire again, so it's exciting to be back again. Today we're going to be talking about building a free AppSec pipeline. There's a few caveats in that word, so we're going to do our best to kind of explain those. But kind of first, starting off, who am I? I'm not an Atlanta native. I am a Triangle area native. I was born here in the Raleigh area, lived in Knightdale, kind of grew up here and have been here ever since. Spent some time in Wilmington, but I am the manager of the adversarial engineering and DevSecOps teams here at Avalara in Durham. Ray, who gave a talk yesterday, is our team lead over there. I have been doing offensive security basically since I graduated. I've been involved in the security space for a little while now. I'm one of the organizers for the AppSec CTF, so if you're just here for the flag, that's at the end of the talk. That's what we call our retention strategy. You know, it's at the very end. It's the last slide. So you have to stay for the whole talk, unfortunately. I'm sorry. But we are teaching all kinds of things about offensive security, defensive security, and it's a great way to learn. Actually, CTFs kind of in general got me into my career where I am now today. So big fan of CTFs in general, but definitely make sure to check it out in that room right there. Later on in the afternoon, we'll be running all night until noon tomorrow. So yeah, so that's me. Not that important. What is important is this question, and it's a question that's incredibly important and that all of you have to answer it. So of all of these tools up here, which of these are AppSec tools and which of these are Pokemon? I'm going to give you a little second. If I had the Jeopardy jingle in here, how many people see one Pokemon in here? How many people see two? How many people see three? Okay, 3 people get it right. There are 3 Pokemon in this list because people love to name things silly things. So we have 3 Pokemon, pretty good ones, I think, and a bunch of tools that are named funny things. So we're going to be talking about tools today. We're going to talk about AppSec tooling and the things that it can provide for you as an open source developer. So what is this talk about? This talk is about ramen. It's about 10-cent ramen. It's about being as cheap as humanly possible. No, it's an example of open source AppSec tooling, right? This is not going to be the latest and greatest new stuff off the shelf. This is not going to be the stuff that you get hit up on LinkedIn about, trying to spend $100,000 on the new DAST tool that is apparently way better than the DAST tool that you spend $120,000 on. So this is going to be some suggestions on automating your smaller projects, stuff that is open source, stuff that maybe could work depending on licensing if you were working on a smaller project or company, startup type of thing. If you're working on a CTF, if you're working on something like we do and want to kind of get some value out of some tooling that's available, right? I'm just kind of in general a big proponent of making use of the things that you have. So instead of going tool hunting every quarter and trying to buy as much stuff as you can to make the product secure, but really just trying to do what you can with what you have. It's pretty scrappy. It's about saving money. It's about getting the most value for the time that you have and the money and the resources that you have. So this is not a fancy ramen type of dashi style thing. This is not an exhaustive list of all tooling. There's going to be people after the talk that be raise their hand and be like, oh, well, what about this tool? Yeah, sure. There's going to be more tools that exist out there that I don't mention, and that's great. And we can talk about them afterwards. And but this is really kind of just a way to show off some of the more common things that are available and more beneficial. This is not suggestions for enterprise-grade customers. So if you're shipping something and you've got the money for it, shell out for the better tools. I'm all for it. There's lots of benefit to paying for enterprise-grade tooling, but this is not the talk for that, really. And this is not going to be coverage for every language you might be coding in, right? If you come up to me and you say, like, hey, well, does this thing cover COBOL, or I'm writing my thing in, Rust or whatever, like, maybe some of the tools might work on that, but I'm not going to kind of, go towards every single language that's available, just because we're going to try to hit the meat of them. So this is a quote from Contrast Security, and I don't know how much I believe this because I think that I have seen a lot more than this in terms of money. Businesses can expect to pay within the range of 5 to 10 grand on average per application per year. You tell me of a company that has one application, and I will be very surprised. Most companies, it looks like they might have, like Facebook, it might look like they have one application, it's the website. Well, no, they probably have hundreds or maybe thousands of applications supporting that same thing. So multiply that by a lot of money, by a lot of applications, you get a ton of money. I know personally, I've seen those 6-digit contracts go all day long, and people pay it. Because it's useful, right? It's beneficial for people to pay for good tooling, but this is, again, not the talk for that. So just a quick note on application security market share. So we have, the reason we're all here, the reason we can pay for a nice hotel, and the reason that there's a big community around this, and that a lot of us work in application security is because there's a lot of money in it, right? And a lot of us get paid very well to secure applications and make the internet and products and companies a safer place, right? In general, this is just a note that the application security market in general is predicted to hit about $26 to $33 billion. It's a wide spread, but hey, nobody can predict the future. By 2030, this is a compounded annual growth rate of 15 to 25%, somewhere in there. I don't know that whoever wrote this was taking into consideration the current state of the economy, but we'll see how all that pans out as time goes on. But the point here is that security isn't going away, right? We're not going to see a massive pullback in people spending money and time working on securing applications. You might see some slow time in development, but we're still going to see plenty of effort being sent towards securing software. So application security is expensive. It doesn't have to be, right? There's nothing inherently. It doesn't necessarily have to be expensive. We don't have to spend $100 grand just to make sure that we have a secure product. All right. So an assumption here. Who are we? Like in this scenario, what are we doing? So we're a single developer, right? We are sitting at that terrible workstation right there on the right, running something from Compaq, it looks like. We're developing an open source product. We are going to talk a lot about GitHub today, so we are primarily working on something open source. This will be useful to know in terms of licensing. We are developing using popular languages, like I mentioned earlier. We're not going to spend time talking about every single edge case. Our code's stored in GitHub. There are a ton of benefits to different code repositories, and we can talk about GitLab and the benefits that it has. But today I'm going to primarily focus on GitHub just to stay kind of focused. And we have no money. We have $0. I saw a talk online when I was researching this topic that said something to the effect of like running an AppSec program on 17 cents a day. I could not find the recording for that, so mine exists and that one doesn't. But this is going to be $0, right? We're going to go even lower than that. We're going to take it a step further. And I've got a little asterisk over there. Top 5 programming language, I'm going to be talking stuff about like this: JavaScript, Python, Java, C++, PHP. Things that you've seen before. I'm not going to worry about the edge cases so much. So talking about what comprises an AppSec pipeline. So the word is in the title of the talk, and I would hope that you had at least somewhat of an idea before coming into this. But the way that we're going to define it today is talking about a set of tools, a set of ideas that are going to kind of comprise a program where we put in a vulnerable or undeveloped piece of software and get out some actionable results from this. So the first one is threat modeling. We'll go through each of these, so I'm not going to spend too much time on them, but the first one would be threat modeling. That's kind of a step one. SAST, static application security testing. DAST, dynamic application security testing. SCA, software composition and analysis. Secrets detection and vulnerability management. This is kind of what you'll see typically when people refer to an AppSec pipeline. Sometimes people will refer to this kind of like as a DevSecOps pipeline. Sometimes you'll see more pieces to this, fewer, depending on how you want to define it. But this is where we're going to start today. I'm not going to attempt to make the little noise that goes doo-doo-doo. Yeah. So we're starting off with threat modeling. Why do we threat model? Why is why is this even a part of the thing? It's not a tool, right? It's not typically, it's a process. It's not really necessarily a tool, for example. So what is this going to get us? This is going to get us a full view of an application infrastructure. So if you're familiar with threat modeling, basically what this is going to be listing out the components of an application. So it could be something like we have a web server and it talks to a database, and these things are in a security group, or these things are in a subnet, something like that. They're going to have different pieces of the application. If it's a broader application, it's going to be more complex. If it's going to be shorter, it's going to be smaller. But really what this is going to do is it's going to kind of get us an idea and a model of what the application looks like. If you have a infrastructure diagram, that's going to get you a lot of the way there. We're going to start off with that infrastructure diagram. And what this does is it kind of shows us the interactions between these systems. So like if we have a web server and it does talk to a database, we're going to talk about the connection between those two pieces and list out kind of all of the threats, all of the things that could possibly go wrong between the connection between those two systems, and then the remediation or the recommendations for either mitigation or remediation between the two systems. So like, for example, web server, database. We have a connection between them. Maybe we need to make sure that that connection is encrypted. The threat would be somebody on the system could sniff. If it was in a plain text protocol, they could sniff the traffic between them. If the remediation for that effort would be to make sure that we encrypt the transmission between the database and the server. Same thing with like storing credentials. That would be another one. Storing a config file for the database connection with the database connection string on the server itself. Maybe that is a insecure practice. Maybe we want to use a secrets manager or something like that. So that is kind of like the idea of threat modeling, is that we take all of the things that comprise a single application, list out the vulnerabilities in the connections between them, and then talk about the remediations. It is always cheaper to fix something prior to implementation. So I tell my developers this a lot. It's going to be cheaper and better for us to identify a vulnerability and code it correctly the first time, instead of actually just coding something and then waiting for a SAST, DAST report, a pen test, something to come back and say, hey, you messed up. You have to re-architect the entire thing. That's going to take time. Developers don't like it when you tell them that they did something wrong. It is going to be cheaper, because again, that talks about efficiency and cost, to fix something prior to implementation, prior to coding it the first time. It's going to be talking about, the threat model is going to kind of show us where we want to focus our attention. If we have 100 threats for the application, we don't list them alphanumerically and start with A, right? We start with things that are critical. Ranking them correctly is important. Depending on how you want to do that, there's multiple different approaches, but the way that we want to tackle these problems is in a criticality basis, or a criticality risk-based approach. I was hearing, we had a CEO from a prominent threat modeling company talk to us recently about how much security, we were talking about threat modeling, and we're talking about how much security should be spent, or how secure do we want to develop an application. A lot of people will say like, oh, as secure as possible. No, like you don't want to spend 90% of your development time making sure that this thing is absolutely like cutting edge, the most secure piece of software that's ever seen the light of day. We want to make sure that the thing is just enough secure so that it covers the threats that are applicable, and spend no more time than that. There's always going to be vulnerabilities that come up over time. We're always going to be needing to assess our applications on a regular basis, but we do not need to spend all of our time addressing security features, although a lot of us in the room would love to tell our developers to do that, but we can't. So that is kind of the steps on the right side for threat modeling best practices by Spiceworks kind of show the idea of going down the threat modeling list. So I'm going to show off a tool. So this thing is, again, about open source tooling. I have some screenshots, but I'm going to attempt a live demo. And so we are going to talk a little bit about a tool that can help us with threat modeling for free. So we could take a piece of pen and paper and go through and write our diagrams out by on pen and paper, but we could use a tool called ThreatDragon. So ThreatDragon, this is their hosted version of it, is a free open source cross-platform application for creating threat models, drawing them out using kind of like a draw.io style, drawing tool, and going through and identifying vulnerabilities. And so I'm going to just kind of log in with a local session here, just to kind of show off a demo that they have here, assuming it works. This is where we show off the fact that we're hosting the hotel, or we're hosting the infrastructure, the Wi-Fi, and it's not great. And that's why I put slides. That's why I put screenshots in. Let's try this. So you get the tool. It's going to show you something like this, where you kind of can import existing threat models, and they also have the example to explore one. But here is a example of a threat model. This is not super pretty, but it gets to the point across. So on the left side, you see entities and components, things like actors, things like processes, trust boundaries, applications. And so here we show the interactions between our various systems, our various components, and then talk about the threats that are existing in between them. So here, like I said, a credential should be encrypted is an example of a threat that will be that could be modeled here in the threat modeling tool. And it has a description and then mitigation. You have a status showing that if it is open or if it is mitigated. We have a priority here. You can set it kind of however you want. But there's the ability here to kind of export this in a standard manner so that it can be consumed by other tools. But the point here is that if you want to kind of just go the route of keeping track of your infrastructure using something like draw.io or some sort of infrastructure planning tool, Visio, whatever it is, you can more than likely do that. But the tool like this that will allow you to kind of show the threats and keep track of them will help you prioritize. So I talked a bit about GitHub, and we're going to talk quite a bit about it here. So there's going to be some things. When I was looking up information about, what are the best things that we have for kind of free open source tooling, a lot of the things that came up were GitHub. GitHub over the past couple years has really kind of implemented a lot of tools and security features that are great for open source projects. So I'll mention it kind of later in licensing, but a lot of the things that you see here are going to be free for open source projects. And then there's going to be probably some sort of, if it's a private repo, it's probably going to have some sort of cost associated to it, or a limitation at least. So just take these with a grain of salt. I'm assuming that the project that you're working on is open source, or an open repo. So we're going to talk about Dependabot, code scanning, which is SAST, secret scanning, and dependency graphs. Dependency graphs I didn't really mention earlier, but it's a piece of this. So first of all, why software composition analysis? We build software with pieces. Nobody writes every single library that they're using. Nobody's going through and writing, left pad or whatever the library that they use to pad spaces on the side of something to make it look line up correctly, right? We build kind of software on the backs of giants, people say. So we have tons and tons of dependencies, and so one of the most popular things that's being discussed nowadays is supply chain attacks, really kind of talking about how a single piece of vulnerable software can kind of implement vulnerabilities into something that is otherwise secure, right? Through no fault of their own. Somebody had to use a piece of a library for their development, and if they do not take a copy of that, pin it, put it in Artifactory or whatever, put it in a place where they have a stored copy of it. If they're pulling it programmatically, it can be updated with malicious code, and you might not know it until somebody discovers it and mentions it later on. So it's important to understand your dependencies and understand exactly what you are building. and then being able to set up auto remediation for that. So there are ways, I would say, that if you want to do this last part, the setup auto remediation part, you need to make sure that you have good integration tests. You need to make sure that you have your, making sure that you are not going to create errors in your builds based on like automatically pulling new libraries, because oftentimes something will come up, it'll change a feature, it'll change a method, whatever, and it will break. So we need to make sure that if we're going to do the last piece, then we make sure we have our test suite kind of defined correctly. So if I can, if it's the internet again, let's see if it works. Can I get my dependent bot loading? We'll see. I have a copy of Juice Shop here, which is the OWASP like intentionally vulnerable web application. So obviously it's got a few vulnerabilities here, but I'm trying to pull up the dependent bot here. I might have to go back, rely back on my, well, it does look like it's loading, but I am going to rely back on my screenshots here. So dependabot is the tool within GitHub that kind of shows the identifies the vulnerable dependencies. It is a way that kind of shows like, hey, we have this this library is vulnerable. The reason it's vulnerable is this. The suggestion is this. And now it may or may not have a suggestion. Sometimes CVEs are reported and don't have mitigations yet. Sometimes there is no correct mitigation. We have to live with it or mitigate it ourselves. It also has the ability to open pull requests automatically to resolve those alerts. Like I said, make sure that you have the correct test cases in place so that you're not going to automatically break your software. And it helps identify supply chain risk. You can tell somebody that, hey, I have an open source software that is resilient against supply chain attacks, and it sounds like a really cool thing. But so here's an example of what that looks like. So we have over here on the right, you see a few examples. They are rated with criticality, so critical, high, moderate, and you can kind of identify where you want to spend the majority of your time. So using dependabot, which is really just a couple clicks on the GitHub configuration, will allow us to kind of show some of these vulnerabilities and what to do about them. So here you see verification bypass and JSON web token. Versions 2.1 and earlier are affected by this verification bypass vulnerability. We see the patched version, which is the remediation, is just to update to that version. We have some more of the information on the right in terms of tags. But really what we want to do here is kind of keep an eye on this, because it will kind of continuously run over time and show the vulnerabilities that get introduced to our software. Because, like I said, just because a piece of software is secure today does not mean it will be secure tomorrow. Through no fault of your own, through no changes, there just will be things discovered because of you folks. Like that is the people that are security researchers out here finding vulnerabilities in open source pieces of software, or reporting them, which we love. We love to see it, but this is going to be something to keep track of. So we're going to move on to the next piece here. Looks like we are about on track in terms of time. So the next piece is code scanning. Code scanning in terms of the way that GitHub refers to it. So SAST is typically what you see. So static application security testing is a way of kind of looking at code as it exists within the repo and identifying vulnerabilities based on what it believes, assuming it executed the way that it is expecting it to, can show a vulnerability. This is free for public repos. I was actually very surprised when I saw some of these, when I was doing some research for this, and how good it is now. I was not always like this. The default scanner, you actually can, I'll show later, you can load in other scanners, but the default one is CodeQL. It supports a ton of languages. And so it supports third-party scanning tools, which I thought was great. You can import third-party results via the serif format and output it as well, static analysis results interchange format, because everything needs to have a standard format these days. And so I guess JSON wasn't good enough. So we have the ability to kind of kick off these scans as, so maybe we want to do it at deploy time or commit time. We have the ability to kind of run these scans on a regular basis. Code scanning is very important for finding things that are going to be identifiable without execution of the code. So we'll talk about DAST later, but SAST is really good at finding things like SQL injection, right? You don't have a, you're not using parameterized queries here. You're going to have a fair amount of false positive rate here because of that. So just because I'm not using a parameterized query in a SQL command does not necessarily mean that it's vulnerable to SQL injection based on however it executes and what kind of data it's being pulled in. However, it might be. So just take that with a grain of salt. Every time that we do SAST, we're going to have to validate this stuff on our own. So here's an example of kind of what code scanning would kind of give you here. Right, it gave me 91 results based on this intentionally vulnerable piece of software. If I could scroll down, I would see that hard-coded credentials, there's more than just that. Let me see. Dependabot loaded, here you go. There's some examples of that. So go back to code scanning. I love Wi-Fi. Go bar go. There you go. We have 91 open vulnerabilities here. You can see that there's lots of different ones that they're going to show you kind of where in the code it thinks that there's going to be a vulnerability. So here looks like we have some comparison here that is being taking some sort of user data, directly evaluating user input. I guess this is an HTTP request parameter as code without properly sanitizing it from the input could result in arbitrary code execution. That is true. It is in the CTF quite a bit. Feel free to check that out, use that as a hint. But we have, it'll show you kind of where it detected this, in what commit, and where if, and what to do about it. So here we have this kind of recommendation, an example, kind of what we should do to fix this vulnerability, an example of kind of how you might do it. Like I said, this is not always going to be perfect. You're going to have to, do your real development work and decide what actually needs to get fixed here, because it's just doing its best. And we love it for it. But there's going to be some references here, so hopefully can kind of let you track this down a little bit. But again, prioritizing your backlog in a way that tackles these higher severity things first is going to be the way that you want to approach this, right? You do not want to you don't want to do it by new. You don't want to, you really want to make sure that these are valid. And depending on your, won't fix. This is, I don't care about this one. There's a way that we can kind of get these out of here if we do not care about them. If they are a false positive, which there will be plenty of false positives, or it's used in test and production code, which, So this is a great tool that we can use, and I want to show also that you can do all kinds of cool other things that are not CodeQL. So there's actually a ton, I was, again, very surprised, that there are a ton of different security scanners based on whatever kind of code that you're doing. Maybe you just really prefer a certain type of vendor. Sneak has one here. That's pretty cool. We have the ability to kind of select whatever we want, and they're run on GitHub Actions. So we have the ability to kind of just set a YAML file that defines, this is the scanner that I want to do. I need the results here, so on and so forth, and get results based on this. And one that I saw recently that I think is really great is Dastardly. D-A-S-T, Dastardly. It is the Portswigger. It is Portswigger, as you may know, for burp, is a scanner. And so this is actually the scanner from Burp Pro Scanner, mostly, that is a build straight into your CI/CD pipeline. So if I'll talk about it later, but you'll notice that the Pro version of Burp is the one that has the free automatic DAST scanner that tests the application as you go on. This is that, but it's free. And this is a more recent thing that has come out as far as I can tell. but you can basically tell it what to look at, and it will scan and do results. So I am a fan of using multiple scanners to kind of receive different viewpoints on, different people write different tools that will approach security scanning in a different way. So multiple scanners is not going to hurt you. It may require a little bit more deduplication work and management in the back end, but it's something that we should definitely take a look at and keep going. Yeah, I don't know. So dastardly is, burp is good. It's not great. Like I said, none of this stuff is going to be the utmost top of the line security tool, but everything that gives you benefit is worth doing. So the next thing is secret scanning. This is kind of the one thing in GitHub that I'm kind of least excited about. It's cool for certain cases, but it's not the best. Secret scanning as an idea is supposed to be finding committed secrets like API tokens or database connection strings or something like that, and reporting on them. Now, certain SAST scanners will do this. Certain SAST scanners kind of have it built in, but there is a secret scanning feature within GitHub that works well for certain items. So I mentioned here partner patterns. So what I mean by that is literally like certain partners for GitHub, there's a lot, have certain API tokens that they've defined and have like provided the regex to GitHub to check for. And so things like Alibaba Cloud Access Key ID, the API key for that and the secret, there is a defined pattern for that and defined like definition. And so those things will automatically show up within your, if you commit it, or it will be able to check, and it will also be able to check that it is possibly valid, maybe, depending on that column on the right. So we can see like, hey, we accidentally committed our whatever API key to the repository. We don't want that getting out. We should take note of it, remove it, and make sure you scrub that. Make sure you scrub that Git history. We don't have it in this year's CTF, but I know in the past it's like, we're like, hey, we took the secret out of the GitHub. Like, great, that doesn't matter. It's in the GitHub keeps track of revisions. It's going to show that you changed it in the history. But stuff like this is important, and there are also other GitHub actions that might be useful in this for free. Again, Truffle Hog. I love pigs. Pigs are my favorite animal, and this is a great tool. This thing will find all kinds of other secrets as well. It exists as a GitHub action. You can just download the command line interface tool and scan other people's repos if you want. But again, this is a great way to find like all kinds of cool stuff, Slack, webhooks, and all kinds of cool stuff. It's a way for us to kind of show or find leaked credentials. It works pretty darn well. I would highly recommend playing around with this in the future if you do get a chance. But in terms of your pipeline, you can implement this GitHub action as a piece of your AppSec pipeline, and try to find some things that you committed by accident. Next, dependency graphs. So this is not really a piece of an AppSec pipeline, but I do find it interesting because it is a feature that's available in GitHub for free. This will kind of show the dependent libraries. We talked about SCA earlier. This is kind of going to show your direct and indirect, which transitive is what that's called, dependencies, and export an SBOM, software bill of materials, in a standardized format. So if you are looking to use a piece of software in another piece of software, depending on audit requirements or something like that, sometimes there are requirements for you to have a software bill of materials, basically showing all of the things that compose this, because we care about licensing, right? So an example of what this looks like will be kind of the various dependencies listed out, and instead of listing the vulnerabilities, although it does here on the right, you see the JSON Web Token has one critical. We are able to, the button on the right, export SBOM, we're able to kind of take all of the pieces of the software, of the libraries that kind of compose this entire repo, and export them out. And so we have a nice list of them. It's useful for other things that are not necessarily security related, but just wanted to make mention of it. It's a free thing that's available, and if it fits your requirements, then it's something to kind of keep a look at. So, moving on to DAST. DAST is dynamic application security testing. So as opposed to looking at code as it sits in a repo and doing analysis on it and making sure that it is secure as it can be, this actually takes a live, running piece of software and does actual attacks against it to try to find vulnerabilities. This helps us find problems easily, catch the CVEs that we know about, things that get put into the DAST scanners. So when something drops the latest hot, spooky SSL or whatever the latest hotness vulnerability is, it's not necessarily going to make it into the scanner that day. Maybe it might take a couple days for them to write, but a lot of times stuff like Heartbleed's going to be in every single DAST scanner that exists, right? You're going to have the common vulnerabilities are represented within a DAST scanner. This is kind of a proactive effort thing. We want to run these scans before we kind of ship things out to production or make sure that they get promoted out to the main branch. There are fewer false positives within DAST. Not to say that there won't be, because there will be plenty. But there are going to be fewer false positives within running DAST because it is trying to actually execute those attacks on a system. We can work it into the build pipeline, like I showed earlier. We talked about getting dastardly into our GitHub Actions. We can have it run against a active system. And then it kind of emulates public scanning. I kind of think of this as like, hey, if you're going to put something on the internet, it's going to get scanned. It's going to get hit by every public scanner that exists out there. This is kind of like that. So there's more rarely are people doing actual targeted hands-on keyboard attacks against a bunch of systems and servers. But there are going to constantly be scanners hitting everything on the internet. So if you're not running DAST, you're kind of going to get it regardless. It's going to happen if you host something on the internet and it's public. If we're talking about DAST, one thing that people typically talk about is OWASP ZAP. ZAP is a scanner that will also execute the application and try to run and find vulnerabilities against it. So here you see an example of a YAML file that is defining how often this thing runs. Here you see the cron job there at the top, where it runs and what it's running against the target. And so you're like, oh, but hey, it needs to have an executing application. That requires money, right? We need to have it on a system that runs all the time. How do we do that for free? Boom. GCP does it for free. So you can do you can have some sort of systems running on GCP or AWS. There are free tiers. They're not going to be great, but they will do the job. You're obviously able to host something locally. If we're talking about free stuff, maybe you go pilfer a computer out of a dump somewhere. Maybe, I guess electricity's not free, solar is, I guess. But there are the ability to kind of have some sort of running application for free within the cloud, which is great. GCP offers one free E2 micro VM per month. AWS offers 750 hours of T2 micro. We have some of the CTF running in some of these free tiers and stuff. So it is possible to run an application that will support a DAST scan within a free tier of product. Here is just an example of all the different services that Google Cloud provides that are free. If this was a page, it would scroll. But there are a ton of things. Compute Engine is probably the one that you care about most often, but there's a ton of things like Cloud Run, stateless containers. If you have your system built in a stateless container and you want to support 2 million requests per month, but that's a ton for a single small application. You can do it for free. So I would highly recommend exploring some of these options. There are lots of things available to you from Google Cloud, AWS. I'm cheap, so it's a good way to kind of host some of your own things for free. If you don't want to run your computer all the time or keep it up, it's a good thing. So next piece is vulnerability management, and why is vulnerability management kind of a piece of the AppSec pipeline? It's not really necessarily a tool. Vulnerability management is an important thing because graphs are pretty to look at. No, it's a good thing because it kind of shows where we are, where we've been, where we're going in terms of keeping track of these things. So like I mentioned earlier, we showed off like, hey, we've got 91 vulnerabilities here. If we keep track of these things and we manage them in a more enterprise-style way, we can show that, hey, our software is getting more secure over time, or it's getting less secure over time based on the number of vulnerabilities or and the criticality of those things. There are a few different tools that we can look at here. If you want to integrate into a ticket management system, there are ticket management systems that are free. Jira does have actually a free tier, again. Not for multiple, not for many users. Is it 10 users? So it's pretty solid for what's available. But again, if you're going to be a single developer or a small group of developers working on something, the collaboration effort between working out of a vulnerability management system is worth it, because you're going to have just that organization that's going to be beneficial, and prioritizing it based on risk is the way that we need to approach everything. So this one I don't have to worry about because I ran it locally. So there's a tool called ArcherySec. It's just kind of like as good as I could find in terms of a robust kind of vulnerability management tool that you can get for free. A lot of these things that you'll see work will show the graphs and will allow you to kick off scans. So like if you have multiple different scans that you want to either upload a report from that or kick off a scan from the tool, so we can launch scans here. Launch scans. We can launch dynamic scans here based on the URL, and then they have like Zap available here, and so on and so forth. A lot of the things that I showed off with GitHub Actions are available here as well. But a cool thing is that you could kind of use this a little bit as like middleware for getting it out to Jira. So we have the ability to kick these things out into Jira and format the tickets into a way that we can manage it and prioritize correctly. So the example kind of thing that I'm showing here is, we see vulnerability trends over time, how many vulnerabilities we have. If you work in application security, I know that you've seen these types of things till you're red in the face, so I'm not going to spend too much time here. But I do think that they're important. That we have the ability to kind of kick things out to Jira, kick things out to email. Depending on what kind of workflow works best for you, it's worth customizing and managing your vulnerabilities kind of together. The next piece here is pen testing. Hey, that's our favorite. So pen testing is not necessarily a piece of a pipeline because it is kind of typically done a little bit more manually. So obviously tools that we all love here, Burp Community Edition. It doesn't have all of the features, but it's a pretty good one. Kali Linux. I don't know if anybody's actually heard of Kali Linux here. It's kind of like an underground thing. So it's obviously free, and there's tons of tools available. People are going to, the day that you learn about SQL injection, you're learning about SQL map. It's in Kali Linux, and so a lot of the tools that are available there are very, 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 very useful. Metasploit is, again, there's Metasploit Pro, but that's an enterprise grade thing. We don't talk about that. But there is, tons of built-in vulnerability or built-in vulnerability scans within that tool as well. Researchers like you are going to pen test other people's stuff for free. It's great. It's called vulnerability disclosure programs, right? We have the ability to kind of accept vulnerabilities. There's actually another GitHub feature that allows you to define a way to submit vulnerabilities to that person, the person that created the repo, and define how they accept vulnerabilities and like it's like some people need time to triage them and so on and so forth, but the responsible disclosure program, right? Fiverr is not free, but if you want to pay, Joe's pen test shop on Fiverr to get a Nikto scan for $5 or whatever you can. But we don't do that because it's not free. So I talked about Burp Community Edition. I'm still a big fan of the free edition, even though it is like $300 for the pro one forever. There's still a lot you can do here, especially considering we talked about Dastardly getting put in the GitHub Actions kind of towards the beginning of this talk. You're going to miss a lot of the automated stuff here, but a lot of the like pointed pen testing, a lot of the pointed tests are going to be important here and available. So this is a great tool. Burp is like if you haven't used Burp before, go over to that room and somebody will have it pulled up on their machine, obviously, for the CTF. So it's a great tool to be involved with, and also is it Kali.tools, the website that will kind of show you all of the different tools that are available within the project. Based on whatever type of vulnerability that you're looking for, there's going to be something, probably going to be something in Kali available to you for free to pointedly test something. So one more thing that I wanted to mention was licensing. So we need to be careful when we're talking about the tools that we use because they can be licensed differently. When I was doing research on this, there were a ton of things that were like, okay, this thing is free to use for the community, this thing is free to use for 7 days, this thing is free for open source projects, this thing is free for academics, this thing is free for only one application. How do you define an application? I don't know. Maybe the type of user, so like saying like, hey, if you are if you're a nonprofit, maybe you'll be able to use this stuff for free, but if you, make money, then not. So just be very careful in examining your licensing, not only from an SCA perspective, right? We need to make sure that the things that we are building our software with are licensed for distribution. If we package them into our system and kind of use it in the community, we need to make sure that the licenses for that are relevant, but also just for the tooling that we're using in general. So a lot of things that I mentioned today are specifically for open source tooling, so maybe you don't want to go start doing this for your applications at work, but it is something to kind of just keep in the back of your head. And then also, this is not part of a pipeline, but I think it's really important that we don't forget the fact that training can be the most beneficial thing we do in terms of like being an application developer for security. Training really, it will make it so that not only like can we address the things that are found within the scans, but also that we are able to find things outside of that, right? Because the scanning tools, as great as they are, they're not going to find every vulnerability. So go on YouTube. There's a million things about how to secure your applications. There are plenty of great lists curated on GitHub. Again, Pentester Lab, Hack the Box, Code Academy, the AppSec CTF shout out. That if you're going to want to learn something about application security, we've got plenty of opportunities, and somebody's going to be over there who is excited to teach you about something. Ray's blog, he's got plenty of write-ups. I don't need to harp on this slide for long. You know that there's training available online for you. Please spend some time learning. I know it's very easy to get caught up in your day-to-day job and not really find time to learn something, but the more that we do, the better that we're going to be in terms of being great application developers, secure application developers. And with that wraps things up. So start free. If the licensing fits, start with something free. Identify vulnerabilities. Start work on them, because if you have the option between running a free scan, starting your stuff, or starting a $100,000 contract the day of, and then realizing that you've got months of work that you can't even you can't start on, you're going to burn a lot of money there. Explore open source just in general. If you're unfamiliar with kind of the concept of open source, I don't know how you sat through this talk, but if you haven't, please consider looking through somebody else's open source project, find vulnerabilities, be kind, report them. And then, AppSec is for everybody. Anybody that is involved in the development of software is going to be responsible in some way for security. So I've got 5 minutes left for questions. What does that look like? It looks like a flag, yeah, okay. So if you're on the AppSec CTF, there you go. This is called a retention strategy. You can put it at the very end, and then everybody has to stay for the whole talk. So anyways, does anybody have questions? We've got 5 minutes. What's up? Right.
Does Dragon do any automatic stuff, like the really expensive threat modelers? Like, if you point it at your repo, will it take in some of the stuff from
So is OWASP Threat Dragon going to provide some of those automated insights? Probably not as much as what you're expecting. It's not really going to, it's going to require some manual effort and some brain power behind those things. But
does Threat Dragon have any sort of like version control so that you iterate and conduct threat modeling like more each quarter, and you're able to kind of iterate fast?
So you do have the ability, like over time. I wish this would load. You are able to kind of. Oh, come on, really? That's all right. You are kind of able to like add in multiple versions of an application and kind of show like, hey, the infrastructure changed from 1.1 to 1.2, and you could export the same. You could export that threat model and then re-import it again as a new number. So you would have the different versions. It's not just it's not the single tool is not going to service just a single application, right? You could iterate through it. I'm sorry, it won't load. I should have hosted this one myself too. Any other questions? What's up?
You noted a lot of different tools
Mm-hmm.
that are all going to produce that don't always produce the same results or the same
Sure.
format.
Yeah.
Is there any way, any cheap, free, or otherwise good ways to normalize the data that you would get from all of these?
Yeah, so the question was, you're going to get disparate formats based on how you, based on the different tools that kind of come out. That's kind of where a threat threat management platform kind of comes in. You do kind of want to, if you want to normalize your response to vulnerability remediation, you would kind of get it kind of pushed into a single platform, and then that would push it out to your ticket management platform, if that's what you want to do, or you could just manage it straight from here. But that is kind of the point of a threat management platform, is that you are going to deal with a ton of connectors between them. So you would have a connector, your SAST scan would kind of export, let's just say, as XML, and it would get import into that platform, and then manage it that way. You're right that different types of AppSec, the different pieces of the pipeline have different standards for how that they, export. Yeah. Yep. 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 It is a problem, and there are, you're mentioning enterprise stuff, and there are enterprise grade tools that do that. And they charge a pretty penny for it, but it is a difficult thing to manage. Is the different results that you're going to get from those different tools. So I would say consolidate them in a single platform if possible. Deal with your ticket management as needed. Any other questions? Great, thank you.